There is no crane on the ground here. Everything you can see on top of this wall, the formwork, the 4 decks of scaffold, 6 traveling cranes, and every man working that morning is bolted to the concrete of the tower itself. In the next few minutes you will see the load path that held all of it, and the strength test that nobody had ever run. Because when investigators went looking for the part that broke, they tested every cable, every bolt, and every hoist on this structure. All of them passed. On the Ohio River in West Virginia, a second cooling tower was going up at the Pleasance Power Station at a place called Willow Island. Finished, it would have been a hyperbolic shell more than 400 feet tall. On the morning of the 27th of April, 1978, it had reached 166 feet, a ring of concrete 342 feet across at its base, standing on 80 slender diagonal columns, with 96 ribs running up the outside. The wall itself was only a few inches thick, and that wall was carrying everything. Above the 10th lift, the ground cranes stopped being useful, and the tower began to build itself. The system worked like this. Special anchor bolts were pushed straight through the wall, clamping an aluminium beam against the inside face and another against the outside face. Steel jacking frames rode up and down those beams on wheels, driven by a hydraulic ram that ratcheted against welded lugs. The formwork that shaped the next pour hung off the jacking frames. A scaffold, 4 levels deep, hung off them too. And 6 gantry cranes stood on top of the wall, each one on 4 legs bolted to those same frames. Nothing touched the ground. The report puts it in one flat sentence. The whole apparatus traveled up the tower with no support other than from the partially completed structure of partially matured concrete. Every day the tower grew by exactly 5 feet, and every day it grew the same way. Carpenters arrived at 5:30 and stripped the wedges and the plywood forms. At the same time, laborers went along the wall taking the bolts out of the lower beams because those beams had to leapfrog up to the top. By 8:30, the whole assembly was jacked to its new height. At 10, the first bucket of concrete came up. Concreting always started at cranes number 4 and 5, then ran both ways round the ring. By mid-afternoon, the 5-foot lift was finished. Everyone came down the single scaffold stair, and the next morning it happened again. Lift 28 was poured that way the day before. Consider what that daily routine did to the load path. By the morning of the 27th, the bottom bolts in the lift below had already been taken out. That is step 1, at 5:30. So the weight of the formwork, the scaffold, the cranes and the men was running through the top row of bolts, and the top row of bolts was anchored in lift 28. Investigators were explicit about what those bolts were for. Once the concrete had set, they wrote, the bolts served as the only positive means of transferring all construction loads to the shell, the only positive means, into concrete, poured the previous afternoon. At around 10 o'clock, the first bucket reached crane number 4 and was tipped into wheeled barrows. Crane number 5 took its first bucket and did the same. Then the men standing on the floor of the tower heard a loud cracking sound from the direction of crane number 4. They looked up and saw the second bucket about 2/3 of the way to the top. The static line that steadied it went slack. Down at the hoist, the operator felt the tension drop out of his cable and set the brake. Crane number 4 leaned inward and went over, taking the scaffolding with it. What happened next took about a minute at most. Lift 28 peeled off the top of the wall, the failure radiating around the circumference in both directions at once. The entire topmost band of the tower fell inward. It struck the floor so hard that investigators could not find a single large piece of it afterwards. 51 men were on that scaffold. All of them were killed. It remains the worst construction accident in American history. The tower below the joint was left standing. Because this had killed 51 people, the Occupational Safety and Health Administration asked the National Bureau of Standards to find the cause. And what those engineers did next is the reason this story is worth telling carefully. They did not start with a theory. They went to Willow Island 5 times, took the structure apart, and tried to break every piece of it in a laboratory. 2 of the 6 hoist cables had snapped, both at cranes 4 and 5. So they began there. That looks like an obvious answer. It is not. 10 samples of that cable were pulled apart in a testing machine. They broke on average at 27,260 pounds. The heaviest load that cable ever carried in service was a bucket of concrete and its fittings. Even doubling that figure to allow for the jolt of hoisting, it comes to under 5,000 pounds. The cable had more than 5 times the strength it needed. There was also physical proof of the order of events. Both broken cables had cut grooves 4 and 5 inches deep into the top edge of the wall below, which means they were still whole and still loaded, while the wreckage was already falling past them. The Federal Bureau of Investigation examined the broken ends and found no kinking and no crushing. The cables did not start this. They were snapped by it. So the investigators worked through the rest of the structure the same way, and the pattern held. The anchor bolt assemblies broke at about 40,000 pounds, and the heaviest load the analysis could put into one of them was 16,000. The chain hoist that trimmed the crane's position failed at 15,000 pounds, and it failed by shearing its gears rather than by slipping, which ruled out the crane creeping out of position. The ground anchor that tensioned the static line held 19,000 pounds without slipping once. The crane beam had not buckled. All 4 legs were straight. Every weld was intact. The concrete bucket was still 60 feet below the beam, so it had hit nothing. The report's conclusion on all of it is 1 sentence long. Each of the components did not fail prior to the initiation of the collapse, which leaves the concrete. And here the investigation runs into something uncomfortable. Standard test cylinders had been cast from the same batch that made lift 28. 2 of them were broken in a press. The first, at 24 hours old, took 283 pounds per square inch. The second, at 25 hours, took 299, but the collapse did not happen at 24 hours. About 18 hours had passed since lift 28 was finished, and the part under crane number 4 was poured earlier still, roughly 20 hours before it came off the wall. There was no test result for this concrete at 20 hours old. Nobody had broken a cylinder that young, so the engineers worked backwards from the 24-hour figure to the moment the concrete set, and arrived at an estimate of about 220 pounds per square inch. 2 things about that number deserve saying plainly. The first is that the investigators argued against themselves. They pointed out that the top of a freshly poured wall is weaker than a cylinder standing on the ground, because free water rises to the top and the curing temperature is different, and that the real strength up there could have been as low as 200. They used 220 anyway. The second is that when they modeled the forces in the shell, they left out the jolt of hoisting altogether, and said so, noting that including it would only have raised the loads. Every number in this report is the version most favorable to the structure. With that strength in the wall, the analysis found what you would expect it to find. Stress in lift 28 peaked in the single panel between the 2 ribs that carried crane number 4. At several points there, the calculated forces equaled or exceeded what the shell could take in compression, in bending, and in shear. Crushing would have begun about a foot above the bottom of the lift and run away along the rib, and the failure of any one of those points would have carried the rest of the band with it. The most probable cause, the report concludes, was the imposition of construction loads on the shell before the concrete of lift 28 had gained adequate strength to support them. There is one more detail in that report, and it is the one that stays with me. When investigators examined the lift below, the older, stronger concrete, they found it crushed around the bolt holes. Not everywhere. Only at the ribs where the legs of the cranes had stood. The wall had been taking that punishment for lifts and leaving a record of it in a place nobody was reading. Nothing on this tower broke. A method that asked yesterday's concrete to carry today's crane simply ran out of margin on a morning when the concrete was 4 hours younger than any test anyone had ever run on it.